Okay, this tutorial is a 8th grade task, an 8th grade standard here in Florida. This is graphing linear equations using slope-intercept form. Sorry for that, I kind of messed it up, trying to squeeze it in there. So slope-intercept form it's commonly described as y equals mx plus b. Okay, m is a typical letter we use for slope. Okay, which we know is rise over run. And b is what we call the y-intercept. All right. Now you should be familiar with x and y. Those are the values of x and y. So if you recall, going back to using a table, right? The x and y table. Sometimes they're drawn out horizontally like this. Sometimes you'll see them vertically, but I'll just leave it as a horizontal table. So you got your x values and your y values, and if you recall, before you would had to give 5 different x values for any type of equation. So let's say the equation is y equals 2x minus 3. Okay, so let's say that's our equation. Again, it's in this format. It's in the slope-intercept format. Okay, so we're gonna graph that here in a second. But let's just say if we had the table, right? So this is kind of like the other way of doing it. So let's say we come up with some 5 values of x. The easiest ones to use would be like, let's say -2, -1, 0, 1, and 2. Reason being is because what they want to happen is they want to see where the line's going to go, okay, as it's approaching, as it's going across the y-axis, okay. They want to see what's going to happen with that. So that's why we start at 2. So if x is -2, where's y going to be, right? If x is -1, where's that y coordinate going to be? And then when it hits 0, when it hits the y-axis, where's that y going to be? So that's one of the reasons why they use -2, -1, 0, 1, 2. You can use -5, -1, 0, 5, 1, 5. You use a host of different things, but for the most part, we use -2, 1, -1, 0, 1, and 2. So what you're going to do is you're going to plug it in. So you're going to plug in -2 in place of x. So this is going to be 2 times x, which is in this case -2. So 2 times -2 is -4. -4 minus 3 is -7. So that means y equals -7. Same thing with -1. Plug -1 in here. So 2 times -1 is -2. -2 minus 3 is -5. -2 times 0 is 0. 0 minus 3 is -3. Okay, and I don't know if you noticed, but as we're going across here, basically it's increasing by 2. Right? So the next one should be -1, right? So let's go ahead and test that theory out. 1 in place of x. So 2 times 1 is 2. 2 minus 3 is -1. It works out. And then this one's going to be, should be +1. But let's see. 2 times 2 is 4. 4 minus 3 is 1. So that works out. And then what you're going to do is you're going to graph those ordered pairs. So -2, -7, that's an ordered pair. You plot it. So -2, -7, 1, 2, 3, 4, 5, 6, 7. That's -2, -7. Then -1, -5, -1, -5, 1, 2, 3, 4, 5. So -1, -5, 0, -3, 1, 2, 3. Then 1, -1, 1, -1. Then 2, 1. 1, 2, 1. So using a table, you would graph all 5 points. You would take a ruler, and then you would basically just create a straight line Let's see if I can do this. Easier said than done, I think, at times. Okay. There we go. All right. So I'm going to try to do this without ruining my ordered pairs too much. There we go. So that's going to be your equation using a table, all right? Now that method takes a while. Okay, do you see that? So it takes a little while to do. And that's usually the less preferred one to use. Using a table, putting in values for x, right? Finding out your y, and then plotting those points. One of the easiest things to do is using this format, the slope-intercept form. So I'm going to show you that here now. So using the same equation, y equals 2x minus 3. Okay, we're going to draw our y axis. Okay, draw our x-axis. And you might be realizing I'm using a pen, and I don't normally use pens for math, but because of this document camera, it's hard to see the pencil. The lead typically reflects, so it's hard to see. So I use a pen, so it's just easier to see on the document camera. So if I make a mistake, you usually have to refilm, do the video again, and it just takes a while. But anyways, hopefully we won't have to refilm this one. All right, so again, so the 2 is, remember, this is the x, right? This is the m, and this is the b, right? So remember, m represents slope. The b represents the y-intercept. Okay? So remember, y equals mx plus b. Now, the easiest way to start is you start with your y-intercept. Your y-intercept is going to be your starting point. Now, what that means is, so the y-intercept is, where does the line cross? So if this is my, let's say this is my equation. Let's say the pencil is my equation. If I cross the y-axis, where do I cross the y-axis at? At what point do I cross it at? Okay? Now, in this situation, -3. So if you look for -3 on the y-axis, -3 is right, let's see, 1, 2, 3. So what that means is, that means that this line, this linear equation is going to cross the y-axis at this point. Okay? It might go this way, it might go this way, it might go this way. We don't know just based on the -3. All we can tell is that that line will cross that point here. We just don't know the slope right now, just by looking at that. So that's your starting point. So start at -3. The second thing you're going to do is apply the slope. Now, if you look, the slope is 2. Well, how do we figure out what slope is? If it's just a 2, what does that tell us? So remember, slope is also what we consider as rise over run. Right? It's typically in a fraction format. This is not a fraction. 2 is not a fraction. So how do we make that a fraction? We set it over 1. So what that means is the rise is going to be 2, the run is going to be 1. So what you're going to do is you're going to start from here. This is your starting point, -3. You're going to go up to 1, 2 over 1. Make a dot. Apply the slope again. Go up 2 from here, 1, 2 over 1. Apply the slope again, 1, 2 over 1. And you can even go backwards. So if I were to go backwards, I would go down 2 over 1, so down 2 over 1, but in this case, I wouldn't go to the right one, I'd go to the left because I'm going backwards, right? But you can do the same thing there. You can simply make a line. Once you get, all you really need is two dots, really. I just make a couple just kind of show you what it looks like, but basically, it's going to look like this. Okay? And if you recall the other graph, right? Do you see a similarity there? It's the same graph. But this one is a lot quicker to do. Y equals 2x minus 3. And I typically label them. Okay? Because sometimes we put more graphs than just one on there. All right, let's do one more. So let's say y equals, let's do negative 3x plus 1. Okay? So if we do that one, this is your starting point. Your y-intercept is your starting point. So where's positive 1 on the y-axis? Right here. That's positive 1. That's your starting point. Then your slope is negative 3. Remember, set it over 1 since it's not a fraction. So negative 3 over 1. So it means it's going to go down 3 over 1. Remember, the run is always going to be positive. So we go down 3. 1, 2, 3 over 1. 1, 2, 3 over 1. And you only need 2, but here I'm just going to do 3. Okay, and then what we're going to do is going to connect the dots. And that's it. And that is our equation. So our equation is y equals negative 3x plus 1. So eventually what's going to happen is when you get used to doing this, you should be able to graph these honestly within 10 to 15 seconds. Okay, as fast as you can write. And that's basically it. This is how we graph linear equations using slope-intercept form. Hope you've enjoyed it. God bless.